In Chapter 9, we're going to go inside the atom and look at what the electrons are doing. We're also going to do very little math. So if you didn't like the math in Chapters 8 and 7, you'll get a break from it here. This is a picture of the Hindenburg. The Hindenburg was a dirigible, in other words, a large blimp that was filled with hydrogen gas. Hydrogen gas floats better than helium, but it's also very flammable, very reactive. And the Hindenburg came to a very tragic end, killing 36 of the 97 passengers on board. Why is hydrogen so reactive and flammable? That's a rhetorical question. Modern blimps are filled with helium. I'm pretty sure they photoshopped this. I don't think TRO Introductory Chemistry has its own blimp flying over a football stadium. That'd be funny, huh? Modern blimps are filled with helium. Helium does not burn. Helium is very inert. Why? Why is helium inert? We're going to look at a couple of models of the atom that will help to explain the inertness of helium, the reactivity of other elements like hydrogen. And it's also going to help us to understand some of the behaviors that form patterns in the periodic table. We see these patterns especially in the groups. So hydrogen is in group 1. Hydrogen is very reactive. The other metals in group 1 like lithium and sodium are also very reactive. If you throw a chunk of sodium in some water, it will explode. It's a pretty dangerous thing. Helium is one of the noble gases. The other noble gases, neon, argon, krypton, xenon, are also very inert. They don't react with much of anything. And so models and theories can help us explain these observed behaviors. Remember, way back at the beginning, we talked about laws and theories. And a theory, it tries to explain why something happens. A law just states what happens. So we're going to look at two important models, the BOHR model and the quantum mechanical model. And these help us to understand the periodic law. The periodic law says that when the elements are arranged in order of increasing atomic number, certain sets of properties recur periodically. So we've talked a little bit about the periodic table and how the atoms are arranged by number of protons in their nucleus. And then we see these patterns occurring. And what's up with that? So the models are going to help us to understand what the electrons are doing. We've talked about the protons and the neutrons. We said those are in the nucleus. The nucleus is very small, very dense, and that the electrons are outside. And they're doing, we didn't really say what they were doing. So now we're going to talk about what the electrons are doing. Some of the comments of the famous scientists that worked on these models are pretty interesting. Niels Bohr developed the Bohr model. He was also involved with the quantum mechanical model. And he said anyone who is not shocked by quantum mechanics has not understood it. Erwin Schrödinger did a lot of the calculations for the quantum mechanical model, and he said, I don't like it, and I'm sorry I ever had anything to do with it. These scientists discovered something that was very confusing and puzzling, and just, it's not what they were wanting to find. Albert Einstein, you've probably heard of him. His response to the quantum mechanical model of the atom is God does not play dice with the universe. And there are some aspects of quantum mechanics that seem like it's just very random chance. So quantum mechanical model it's very important, but it's a model that people are still really working on because I don't know that anyone really understands it because it's just kind of crazy stuff. But it's really important. It forms the basis of the modern periodic table, and it guides our understanding of chemical bonding. And our understanding of the quantum mechanical model of the atom helps us as we develop new drugs And as we develop new semiconductor devices, you know, most of us have an amazing piece of technology in our pockets, a cell phone. These things can, I mean, when I was in high school, there was nothing that could do this, what a simple cell phone can do. To do something as even close to that would require a computer the size of a large building. It was crazy. I mean, the developments have just been amazing. And part of that has been because we're understanding how the atom works. And so we're able to make these electronic devices that are smaller and smaller and smaller. There is a finite limit to how small they can make those things.